it may be far more likely that we are alone for millions or even billions of light years in every direction.
Europa is far more dynamic than we'd imagined. And it's this dynamism that makes it a tantalizing target in our search for life under the ice. At its simplest, life needs three things: water, energy, and the right chemical ingredients. Europa has the first two in abundance, but the chemistry for life is missing. But fortunately, Europa is not alone. Orbiting close by, Io has the missing ingredients we believe necessary for life in abundance. Erupting into space in enormous quantities around Jupiter.
Here's where the story gets even more wonderful, because the volcanoes of Io are constantly producing chemicals, materials that rain down onto the frozen surface of Europa. But if it wasn't for the geology, then they'd be separated forever from the ocean below by 10 or 20 kilometers of ice. But that active geology, creating the plate tectonic-like behavior, can bring those materials, those chemicals, into the ocean. And then we have all the conditions we think are necessary for the origin of life.
So Europa's dynamic surface may form part of an extraordinary ecosystem. One that stretches from one moon to another. And work is already underway to send robotic probes into that distant icy ocean.
It would be a profound discovery to find life on Europa, but it would also be profound if we didn't, because everything we think we know about the origin of life, all the ingredients that are necessary, seem to be present on Europa. So if we go there and send a cryobot into the oceans of Europa and find nothing at all, then it may be far more likely that we are alone for millions or even billions of light years in every direction.